Rama. Do you go by Rama?
Yep.
Ramakrishna is a product owner with steer-by-wire technology at General Motors. I know you just did your introduction a few moments ago. So you've been around for at least 10 years working in this industry. And so we're relying on you to kind of get a broad understanding of your experience in steer-by-wire technology and what that means for autonomous vehicles as we move forward. So without further ado, I'll let you take over. Let me just go through get you to the next slide and go ahead.
I have a short presentation. I think it's the last presentation before lunch. So hopefully we can quickly go through this, and please interrupt me if there are any questions. Like I mentioned, I've been working in steering, started as a mechanical, design engineer, developing the EPS systems, like the mechanical hardware rack and pinion. And recently, a few years ago, I switched to the software and electronic hardware design. So you can see the title is product owner. It's a safe, agile role. So I am responsible for both electronic hardware and software for the steering system. My topic today is software-defined vehicle. It's a new terminology, new process, which I think every OEM is trying. So what is software-defined vehicle? Software-defined vehicle refers to the ability to upgrade a car throughout its lifetime through a centralized architecture. So GM architecture is called Ultify. So it's basically a new architecture which will allow better upgradable, device, almost like a smartphone where you have upgrades, quick updates, and you have, Apple, getting a new software version, and all of a sudden it's a completely new hardware and software, right? You have a new phone, you feel like you have a new phone. So that's the concept of software-defined vehicle. And how is it different? It's going from a hardware-focused approach to a software-focused approach. So reimagining the car with software at the center. So we talked about, how agile process can be used for hardware. We can skip all these steps and come up with the hardware. But I think with this SDV, so the acronym like SDV, it's more, software based. So it's not a steering software or steering hardware. It's more like a package of software with steering, brakes, and everything integrated. So how it is impacting the customer, it's going to give improved driving experience. So benefits of software-defined vehicle, faster development and integration of new features throughout the vehicle lifecycle directly into the cloud. So with this centralized architecture, you have better flexibility from the OEM side to come up with new features, which will help the driver. It can be driver specific. Like if I have certain driving habits, it might be specific to my driving habits. You can come up with a feature for that. Again, it all depends on, what the regulations are from a data security standpoint, which we discussed earlier. But if there is an access to the data, what individual driving habits are, or what the driving pattern is, we can come up with a unique algorithm or unique feature for the specific driver. So again, that's the second point. Also, it's different personalization option for the customer. Depending on what their needs are, we can come up with that option. The other benefit is faster prognostic for issues with real-time software updates. So you can say if you have a hardware issue, which might be driving a recall, kind of situation, replacing that hardware might be expensive. You have to, millions of dollars for recall. So instead of doing that, it'll be still called a recall, but it'll be a software fix for that hardware issue. So that's the benefit of having this kind of centralized setup. Like if you are able to do that, you can save that, recall cost from an OEM standpoint. Prognostics, like I said earlier, you have all this data available. So if you have anything specific, you can go through data analysis and figure out what specifically is causing that issue. So you have opportunities for prognostics with those available data. Higher efficiency with DevOps, automated and virtual testing, software modularity, reusability, new ways of working. So you can have same software across multiple programs, multiple like truck versus car. You can do multiple things with the software. So that's one other benefit. Upgrades, subscriptions, loyalty programs. Like I said earlier, it'll be almost like a smartphone. So if you need a particular feature, you can subscribe to that. Like say you are going up north and you need heated seats, or that's the wrong example, but you need like rear steering, for example, right, for a vehicle, or towing capability with rear steering. You can subscribe to that. You need lane keep assist. That's like a base feature now, but it can be based on when you need it. You can turn it on, you can turn it off if you don't need it. So it opens up a new revenue stream for OEMs with having that option. You can also, get into this loyalty program depending on different how we want to do it from an OEM standpoint. Data analytics and OTA updates. Like I said earlier, you have a lot of data, you have access to more data than you need. It depends on, if you have an issue and if you want to come up with a solution, you have that option to go through that and come up with a fix. And everything can be over there updated to come up with a software update. So that's an option too. Enhanced safety with real-time diagnostics. So touched upon that. So how does it look like? Where, traditionally we had multiple software in different hardware levels, right? And everyone had that control. And you had, like, say, you need a particular signal, say vehicle speed. Each module or each, say, brakes module will do their own software calculation algorithm to come up with the vehicle speed. So it's taking more computational space. It's inefficient. So with the centralized architecture, you can optimize the space you use, and you don't have the same amount of it's like you can share that data with multiple modules or multiple systems. So that's one of the benefits of having the centralized system. So going to the steering system, I just thought, I'm talking more from a steering system perspective. It was more, hydraulic power steering. Started with the EPS, and we had autonomous, and now we are going into steer-by-wire. So that's, like I said earlier, like drive-by-wire, having the centralized system helps a lot. How we can integrate brakes and steering together, So there are a lot of opportunities having the centralized system. Okay, so what are the opportunities for steering? By-wire adaptation is a big one. Steering integration with other vehicle dynamics features, like all the ADAS feature, if you want to have autonomous features, linking that with the base software will be much easier. Integrating the ADAS software with the steering and brakes is going to be much easier with the software-defined vehicle concept. Vehicle health management. So if you have any issues with the hardware or software, you can detect that much easier with the SDV kind of architecture. Also, it's a new business model now. The traditional suppliers used to provide a black box hardware piece, which met the requirement. Now you also have options to provide software solution. So the way we can envision it, like you can break the software into multiple compartments, right? So if you have a big system, you have multiple software compartments, and each compartment is doing certain tasks. So from a validation standpoint, you don't need to validate. You can validate, or you need to validate it as a system, but you can also validate it at a compartment level. So with the new business model, like if you need like a feature from supplier, you can also get that piece of software code and integrate with your main software. That way, it's not just traditional hardware software combination. It's software based, smaller pieces of software which you'll be buying from a supplier or a third party company. Personalized features based on driver need. Like I said earlier, if you need a particular feature enabled, you have that option. If you're going long drive and you need certain comfort features, you can turn it on. So that those kind of options will be available with the SDV. Innovation. So when you have access to the code from the supplier or even from a overall like multiple modules, like you open up opportunities to integrate brakes and steering, suspension, like all these can work together and come up with new ideas which will enable new features. So a lot of opportunities for innovation from that standpoint. For example, like if you're doing rock crawling and you need certain suspension feature, or you need to prevent some kind of damage, you can reduce the assist from a steering standpoint. So depending on the suspension height, you can adjust that steering control. So a lot of options are, it opens up a lot of opportunities for innovation. Extending platform and subsystem lifespan. So with this, you can restrict, like you can tune it however you want from a software side. So that will enable the lifespan of the overall hardware software. Improved driver experience. So we had the stowable column. Like if you have steer-by-wire system, you can have stowable column option, so that when you're not driving, you can go to a mode where the column can stow back and it'll move away and create some space. So that's just one example, but you can completely, get rid of the steering wheel. So there are a lot of options available when we go to this by-wire technology in general and SDV to enable by-wire. Some of the challenges, I think this is my last slide. Traditionally, we relied on the supplier to do the integration, to do the safety testing, to do requirements development in some cases even. So with the new process, I think we need to make sure the requirements are really understood at from a system, subsystem, this software component level even. So understanding that is very important. And integration process, like how is going to be different. Like now steering, if you're just taking steering, it's not, like I said earlier, it's not the steering software. It's going to be combined with a bunch of other software pieces, right? So how do you integrate them together? Steering plus suspension, like, and come up with that code. And you also need to do the testing. So you need to share that with the supplier, but you don't want to share everything with the supplier if the supplier is responsible for testing. So we need to, like someone said earlier, we need to redefine all the steps or redo the whole process chain. Like we used to do it in a particular way. Now it needs to be redone. Like we need to come up with a new process for that. Some of the enablers for that, like I said earlier, continuous improvement, continuous development. There are tools available from a software side. I think there are certain tool sets available. I was told one of the names is Cucumber, the tool chain, like from IBM, like multiple tool sets are available, which you can use to do this integration testing. But most important thing, if you want to get the software launched, like reduce the software development timing, we need to automate the testing. So coming up with the whole process from developing the code all the way to the system testing and launching it, that needs to be redefined when it comes to SDV. Continuous integration and deployment, alignment. How do you work with multiple modules together, and how do you break it into different, like if you're following the agile process, how do you break it into different sprints? So that's a new concept. So we need to define that, incorporating it into PI planning, stuff like that. Decoupling of hardware from software, that's completely new approach. But it's kind of, there are certain hardware components which are also driving software. But the expectation is we need to decouple the hardware completely from software. So for example, like if one supplier is using one way of having their, hardware level software, you need to have like a universal interface with the software, or you might need like a layer of code which will translate supplier A from supplier B, those inputs or outputs. So that's one strategy which you can implement, or you can dictate what you need from the supplier as well. That's the second strategy. So decoupling the hardware from software is a new thing. So we need to define that and how we want to do it from an OEM standpoint. Failure mode analysis for system will be vastly spread. So like I said earlier, in the past, for EPS, we had everything, we relied on the supplier to do all the testing. They did all the fault injection testing, at a vehicle level or bench level. Now with the new system, we need to figure out how that will be done, because we rely on brakes, we rely on multiple other modules to do steering. So coming up with a strategy for that failure mode analysis, it's how you divide the arts, right? Release train, you have release trains for different modules or solutions, right? So depending on how you divide those, you can come up with a strategy for that. The last one is artificial intelligence, machine learning infrastructures are essential to accelerate development of autonomous driving. So whatever data we get, like how do we process that, and how do we come up with path tracking algorithms? This is still, we need to look into different options for that, and the software should be mature enough to do those kind of evaluations. So I think we are continuously evolving. I think more technology will be coming as we go through this whole process.